this video, we'll look at indirect proof, our final inference rule. So again, instead of starting with the schematic, let's start with an example. So here's a possible argument, 3 premises and a conclusion, R. So for one thing, you could pause and try proving this on your own. It's actually a pretty simple proof that you already have rules to do without using indirect proof or even conditional proof, just using the 5 basic rules. Really, you could just use 2 applications of modus ponens. We have the antecedent of the conditional on line 1 here, so we can get the consequent 1, 3 modus ponens. Now we have the antecedent of the conditional on line 2, so we can use modus ponens to get R. And that could complete our proof. That's a perfectly good proof. But we can prove things in more than one way, which is an interesting thing about proofs. So we're going to learn a new way to prove, well, this particular proof, but in general, just a new rule. So here's how the line of thinking goes. We've got these premises, we've got this conclusion, and I'm going to reason as follows. Let's say R is false. We're trying to prove it's true, but let's say, for the sake of argument, let's assume that R is false. So I'm going to take the negation of R. And then I'm just going to call that an AIP. This is just an assumption for indirect proof, but just assume R is not true. Assume it's false. What would follow from that? Well, now we have the negation of the consequent of the conditional on line 2. So we could get the negation of its antecedent by 2, 4 modus tollens. Now we have the negation of the consequent on line 1. So we can get not P by modus tollens. And look, we have P, but we've also managed to derive not P. That seems bad, if you can derive both P and not P from something. And indeed, we can put these together into a conjunction to make it really clear that what we have derived is a contradiction. We'll use the conjunction rule to do that. So, a statement like this, where we have one conjunct is the negation of the other, exactly the negation of the other. So here's another explicit contradiction. Here's a thing, and here's the negation of exactly that thing. This would count as an explicit contradiction. So what we have on line 7 here is an explicit contradiction. So think about what that means. Our premises are all assumed to be true for the sake of argument. And we've introduced an assumption, and when we did that, we were able to derive a contradiction, something we know is false. If you were to do a truth table for P and not P, it would be false on every row. We know that P and not P is false. That says something like it's both raining and it's not raining. So given that we assumed the premises are true, and this is the only assumption we've made, this must be the reason why we were able to derive something false. All of our inference rules are truth-preserving. That is, if you put true stuff in, you get true stuff out, guaranteed. As in, if you apply the rule to premises you know are true, then the inference you make on the basis of that rule is guaranteed to be true. That's what validity guarantees. So if you ended up deriving something false, you must have introduced a false assumption. So if not R is false, we know that the negation of not R is true. So we've proven R by assuming not R and showing it leads to a contradiction. So what we'll do is we'll close off the subproof once we hit a contradiction like this, an explicit one, a thing conjoined with the negation of that same thing. And then immediately on the next line, we'll put the negation of our AIP. And we'll cite the whole box, 4 through 7, and IP, which stands for Indirect Proof. And that completes our proof and demonstrates how we can use this new rule, indirect proof, to prove something, in particular the negation of something. Okay, let's look at the schematic here and highlight a few details. So again, this little dot thing here says you can start an indirect proof anytime. Maybe it comes first thing in your proof, maybe it comes at the end, maybe it's in the middle. You can start one anytime, so maybe there's a bunch of stuff before you do it. The very first line of your AIP can be any statement whatsoever. There are no restrictions on what you can make your assumption for indirect proof to be. Now, what do you want your assumption to be? Usually, you're going to have some strategy in mind. There's going to be something you want. So the AIP you should choose is the negation of something you want to prove or derive for the sake of proving something else. So that could be anything. You want to derive all kinds of things within the context of a proof. Maybe you want to derive the conclusion, maybe you want to derive something along the way. Anytime you want to derive something and you're not sure how to do it, one thing you could do is assume the negation of that thing and show that it leads to a contradiction. And if you can do that, then you can infer the thing you wanted to prove all along. Okay, so once you have started a subproof and you've chosen your AIP, then your goal is to work your way to deriving an explicit contradiction. And that's important that this is an explicit contradiction. And what that means is you have to derive a thing and the negation of exactly that same thing. It doesn't have to be two atomic statements. Our Greek letters can stand for anything. So if you were to derive if P then Q and the negation of if P then Q, that's a good explicit contradiction, so long as you have a thing and you have the negation of exactly that same thing. Okay, the only time you can end an indirect proof like this, a subproof, is once you've derived that explicit contradiction. And when you do that, the very next line will be the negation of your AIP. Whatever it was, the negation of that is the immediate line after you have closed your subproof. And then you'll justify that by citing all of the lines in the box, including the assumption, including the last line, and the rule is IP for indirect proof. And you'll have some justification for your explicit contradiction. Oftentimes it's going to be conjunction. Since it's a conjunction, in many cases you'll have to put it together using the conjunction rule, but not necessarily. The justification depends on the proof in question. Okay, so those are the elements of the schematic. So just to recap, when you begin an indirect proof, the first line, your assumption for the indirect proof, can be anything, but ideally it will be the negation of something you want, and you will justify it with the letters AIP, assumption for indirect proof. I can't stress enough that your assumption can be anything you want. There's no restriction, so it really depends on what you are trying to prove. You may end or close your subproof only when you have derived an explicit contradiction, and we mean something very specific by that. Once you have closed the proof, the very next line after you have closed it has to be the negation of the AIP. And lastly, just like with conditional proof, once you have closed off this subproof, you cannot cite anything inside of it. Everything you have derived inside of a subproof here depends on an assumption. An assumption, not only is it an assumption that we don't know if it's true or false, like in the case of conditional proof, it's an assumption that we know is false. So everything in here depends on a false assumption. So we don't want to use those when we derive new lines in our proof. So once the subproof is closed off, no citing lines inside of it. Okay, let's do another practice problem. Okay, let's look at an example that uses indirect proof. As usual, I suggest that you pause the video and try working through it on your own. Okay, so where should we get started? So notice that if we try the just do anything you see strategy, there's not really anything we can do. We have 5 rules, we've got 2 that involve conditionals. Line 1 is a conditional, but we don't have the antecedent of that conditional on a line, and we don't have the negation of the consequent on a line, so we can't use any of those rules. We do have a disjunction on a line, but we don't have the negation of either disjunct on a line, so we can't use DS. We can use conjunction, like we could put lines 1 and 2 together into a conjunction with the conjunction rule, but there's no reason to do that since we don't need that complicated conjunction and can't do anything with it. And there are no conjunctions to take apart, so none of our rules work. So we know that we must need one of the rules that uses a subproof, either conditional proof or indirect proof, but which one? And if you're using the just do stuff you see strategy, it can be difficult to figure out what to do, because in order to set up an effective subproof, you need to know what you want before you even get started on setting it up. So if you're thinking you want to do a conditional proof, you need to know which conditional you want. So you might look at line 1 and see that there's a conditional there and be like, oh, maybe I do a conditional proof. A really common thing to do is to try to get this conditional, but there's no reason to want this conditional. We already have it on line 1. So don't look at conditionals you have to figure out what you want, or negated things you have, or anything like that. The idea is, what do you need in order to get cracking on this proof? That should inform your subproof choice. So let's reason backwards as strategically as possible. So what I want is not P and Q ultimately. That would be great. And since I see that there are P's and Q's around in here, and since I don't see any rule that I could use to get it, and there's no conditional I obviously want, and the thing I want is negated, in particular it's a negated conjunction, I'm thinking indirect proof, in part because there's just nothing left to do, but also one thing I notice is, what will my AIP be if this is what I want? My AIP will be the negation of the thing that I want. So it would be P and Q. And that's a really good AIP. To have a conjunction, I can immediately do stuff with it. As in, I could simplify it, and now I have more stuff to work with, and then I'm going to look at the premises and see, would having this stuff play well with this stuff? I immediately see the things I could do with that P and Q. So this is looking like a fruitful strategy. So let's start there. So once I've decided that I want to do an indirect proof, and I've decided that the reason why I'm doing it is because I want to get, at the end of the day, when I'm done, what I want on my new line is this. So I'm going to put the negation, or no, I want the what I want at the end of the day is that. So I'm going to put the negation of that as my AIP. My assumption for indirect proof. Okay, so now I have a new puzzle piece to work with. As I said before, it's a conjunction. Conjunctions, oftentimes, it's just worth taking them apart just because they're extra pieces to work with. But I also see I can use both of those pieces right away. So let's do that. Okay, now I have on line 4 the antecedent of the conditional on line 1. That's a thing I can do. And put the consequent of that conditional on a new line. Citing lines 1 and 4, modus ponens. Now I also have the negation of a disjunct in the disjunction on line 2. So I can put that other disjunct exactly as it is on a new line. Okay, now what? Feels like I'm just going nowhere here, right? But I have new stuff to work with. So what can I do with these new things? Notice that they have P and Q who's in them, and I still have these P's and Q's to work with, and I can use lines more than once. So P here is the negation of a consequent, so I can infer the negation of this antecedent. That's a thing I can do. And I also have a conditional here. Oh wait, that's the thing I just did. I also have a disjunction here, and I have the negation of one of the disjuncts, so I can put that other disjunct on a line. This is looking good. Now I have not X and X, so I'm going to put them together to form a contradiction, an explicit contradiction. Now that I have derived an explicit contradiction, I'll close up my subproof. And the next line, immediately following the subproof, is the negation of the AIP. Which is what we were trying to derive, so we have. So this proof is complete. At this point, not surprisingly, I'm going to suggest that you go do the online practice.